Hello. Okay, finishing it up. Here it is, 2.3, the moon. Okay, let's go forward. Okay, so we got phases of the moon. So we all know that a moon is to go from one full moon to the next full moon, like fully through all the phases, takes about a month. Okay, so the exact amount of time is 27.3. If you Google it, you might see like 29 days, and it's because there's two different types of ways of thinking about orbits. Okay, but I'm going with the 27.3. We can talk about those ways of why that would be confusing or something. If you're interested, we can talk about it. Um, uh, okay, so let's talk about the phases. Now, here's all the phases right here. Okay, so let's first off just like if you're standing on Earth, what you would see. Okay, a crescent is when you see a little sliver of the moon. Okay, that's a crescent moon. Now, when you can see more than half, that's called a gibbous moon. Okay, and so we have now if you notice, there's times when the right hand side is bright, and then there's times where the left hand side is bright. Okay, you call the right hand side the waxing. Okay, so if you ever see the right hand side bright, it's a waxing something moon. Okay, so if you can only see a little sliver, then it's a waxing crescent. If you can see more than half, it's a waxing gibbous. Okay, and then same thing on the left. On the left, it's called a waning. Okay, so if you see the left hand side of the moon is bright, it could be a waning gibbous or a waning crescent. Okay, these are the ones that you get when it's going towards full moon. So if the right hand side of the moon is bright, that means it's going towards a full moon. If the left hand side is bright, that means it's going away from a full moon. It's going to a new moon, or a moon that, no moon, if you want to call it that. So no moon is called new moon. Okay, and then you also have when the first half of it is bright, we call that a first quarter. We don't call it like a waxing half or anything. We call it a first quarter because it's going towards the full moon. If it's the left hand side that is halfway lit up, we call that a last quarter. Okay? And so you need to know all those phases. Okay? Now, how do we get those phases? So, how do we get those phases? I'm going to use this to describe them. Okay, so the moon orbits around us in a counterclockwise motion. That's how all things pretty much in our solar system orbit are counterclockwise. Okay, so let's assume you are this person here. And let me grab a pen. Okay, yeah, red should be fine. Let's say you are that person, and the moon orbits counterclockwise, which is that direction, right? So you have a moon right here. The moon orbits this direction. Okay, well, the sunlight comes from this side, right? The sunlight's coming from over here. Now, half the moon is always lit up because half the moon can always see the sunlight. So let's say right here, this is the dark side. Okay, and I hate how this draws like that. Okay, so this is the dark side and this is the light side. Okay, so this person looking over here can see only this little sliver over here that's lit up. Okay, and notice how that would be his right hand side. So that would be a waxing crescent. Okay, as the moon goes more and more over here, so let's say right here. I know it's hard to draw a circle because the pen's drawing so slow I can't even tell what I'm doing. Okay, so if you're looking at it like this, notice for this person, the right-hand side of the moon would be lit up, and it would be the first quarter, okay? And it would keep going this way, and when it's over here, you would see a larger portion that's lit up, and that would be called the, it would be the right-hand side, so it would be waxing gibbous, because you're seeing a lot of it. Then when it's over here, you are seeing a full moon because anybody standing on the Earth, like let's say they're standing right here, they are going to be looking at it, seeing everything lit up. If you're right here and you're looking at this moon, this is a new moon. You can't see any of the bright part of the moon, okay? So that's called a new moon. And as it goes around, you're getting waxing to the waning, and that's how you do it. Okay? So I hope you guys got all these down. I hope they make sense. Let's go forward. Okay, now notice how from going to a full moon to a full moon takes pretty much almost a month. Okay, and I know you guys have probably heard like a blue moon. Once in a blue moon, right? That's like a saying. All that means is it's the second full moon in 1 month. And it doesn't happen very often because to go from one full moon to another full moon takes about a month. So in order to have a blue moon, that means you have to have a full moon at the beginning of the month and a full moon at the end of the month. And that one at the end of the month would be called the blue moon. It's not actually blue. I have no idea why in the world they call it a blue moon, but they do, and it just means second full moon in 1 month. There's nothing real special about it other than that you had a full moon earlier in the beginning of that month. Okay, everyone always talks about the dark side of the moon. What does that even mean? Like, it's been the Pink Floyd album, Dark Side of the Moon, and people always reference it saying that you never see the dark side of the moon. Yeah? They say that the dark side of the moon is the side of the moon we never see. Because I don't know if you've ever noticed, but when you look at the moon, you always see the same side of the moon. Okay? You don't ever see the other side of the moon. So your entire life, the moon that you've always seen is right here. It feels like it never turns to us because we always see that image of the moon. There's no other image you will ever see of the moon unless you somehow go and get behind it and take a picture. Okay? So they call that other side of the moon, the side that we never see, they call that the dark side of the moon. But it's a bad term. It's a bad term. Let me show you why. Okay, look at this. This is the side of the moon that we always see. Okay? Well, if you look at it, the other side, which we can't see in this case right here, is not dark. It's actually completely lit up. Yeah, so it shouldn't be called the dark side of the moon. It should be called the far side of the moon. The dark side of the moon implies that it's always dark, but it's not always dark. Sometimes it's lit up. If it's a new moon, it's lit up. Now look at it over here. Like if it's at this point in time. Okay, so it's cut in half, and then this is the dark side. Here, the far side of the moon is also the dark side of the moon. You're seeing this right here, and this is the dark side, and it actually makes sense. But like over here, you are seeing this half, right? You're seeing this half. And so people are calling the dark side of the moon this half, the side that they don't see. But look at it, it's not dark. Half of it's lit up, half of it's not. Okay? So whenever people refer to the dark side of the moon, that's an incorrect term. We shouldn't be saying that. We should be saying the far side of the moon. It's the part of the moon that's furthest away from us at all times. It's the stuff we never see. And there are pictures of it if you bring them up. You can look at the far side of the moon because we've sent stuff over there to take pictures. Yeah? Okay. If we only see one side of the moon all the time, what is that? Does that mean that it doesn't rotate? Yeah? So that's a good question here. So look back here. This. So if we're always seeing this side, yeah? So we always see this side. This is the side that we see. If I draw a circle here, this is the side we see, right? Does it rotate? So think about that real quick. If we're always seeing the same side, does it rotate? And the answer is yes. Okay? Now let me explain why. It's rotating as it's turning. Okay? So like I put 2 dots on the side that we always see. So look at this. This side and this side. Okay, the 2 dots is what we see. That means it did a 180-degree turn to go from here to here. Yeah? So it does turn. It does rotate. And what's interesting about the moon is that 1 year equals 1 day. Okay? So 1 year is equal to 1 day. That's why we always see the same side, because the time it takes to orbit Earth once is the time it takes to rotate once. And that is why we always see the same side. So it does rotate, it just takes one full lunar year to rotate once. So, does it rotate? Yes. And we call this, when 1 year is equal to 1 day, we call that synchronous rotation, okay? So the moon rotates exactly once with each orbit. Another way to say that is 1 year equals 1 day, okay? Now, if we had that here on Earth, where 1 year was equal to 1 day, that would mean that one side of the Earth is always facing the sun, and one side of the Earth is always not facing the sun. It never sees the sun. So one side of the Earth is always in day, while the other side of the Earth is always in night. Okay? Obviously, that doesn't happen because 1 day for us is 24 hours, and 1 year for us is 364.25 days, right? So, when 1 year is equal to 1 day, that is called synchronous rotation. So the moon has a synchronous rotation. And this always happens whenever a small, tiny thing is orbiting very close to a large thing. So the moon is small compared to us, so it is locked with us. We call it tidally locked. And that is synchronous rotation will occur whenever that happens. So like all the moons of Jupiter practically are in synchronous rotation with Jupiter. Yeah? Okay. And that means that one side is always the same for that planet, in our case, Earth. Okay. The Earth and the moon cast shadows on each other. Okay. These shadows are called eclipses. Okay, so let's talk about the different eclipses real quick. Okay, we have a lunar eclipse. A lunar eclipse is when the shadow of the Earth is being cast upon the moon. And we call this a blood moon. And it's when the moon appears reddish, okay? And if you Google or YouTube blood moon explain, they will explain why a blood moon looks like that. But I just don't want to go into like a 10-minute explanation and then we have no time to talk about the rest of this stuff. So, a lunar eclipse is when the Earth blocks out the moon. And so this would occur at a full moon, okay? So it would be when a full moon would normally appear to us, okay? Okay, I'm going to ignore that stuff. We will go over that maybe when we're back in person to person. Okay, if the moon is completely blocked of sunlight, why is it red? Okay, I'm not going to go into the blood moon right now. It's going to take a while. Okay, solar eclipses is another thing that you need to know. So solar eclipses happen in a new moon, and it's when the moon is in between the Earth and the sun, and the moon's shadow is cast on the Earth. And that is a solar eclipse, okay? And we get different types of eclipses, okay? You got a partial eclipse, and I have like pictures of what these mean. So partial eclipse is when the moon only blocks out some of the sun. A total eclipse is when it blocks out the full sun for where you're standing, okay? So like let's say you're on Earth, where would you see a partial eclipse here? You would see a partial eclipse if you're standing in this lighter shadow portion, okay? You would see a total eclipse if you're standing in that dark shadow portion. If you see the total eclipse area is much smaller than the partial eclipse area. That's why it's so rare to see a total eclipse in your lifetime because it's so small. The moon is so much smaller than the Earth. Its shadow doesn't really cast a whole lot of shadow on Earth. So there's a picture of a total eclipse. Like right now, if a total eclipse would be if you're standing in that completely dark region, okay? So an annular eclipse. Okay, now remember I said before sometimes the sun is closer or further, the earth is closer or further away from the sun, right? Well, it's the same thing with the moon. Sometimes the moon is closer to the earth and sometimes it's farther away from the earth. Okay, you get total eclipses when it's a little bit closer, and you get annular eclipses when it's a little further away because it doesn't block as much. Okay, so uh, okay, let's write what these things are. When the moon is closer, we call that a perigee. A perigee. And then when it's further, it's an apogee. Okay, so when something is farther away from something, you call it an apogee. When it's closer, you call it perigee. Okay, it's very close. Okay, well, you'll remember now. Okay. Okay, annular moons happen when the moon is farther away from the earth. Okay, so annular eclipses, this happens when it's in its apogee. Okay, when it's farther away. Okay, now, next question. I think this is our last slide. It's close to the last slide, and we're not doing 2.4. Okay, so why doesn't eclipse happen every time there's a full moon? So watch, let me go back and I can present this question easier to this. Okay, if the sun's light is coming from here and the moon is in between the earth and the sun, shouldn't every time we have a new moon, you also have an eclipse? Because the moon is blocking out the sun's rays, right? Shouldn't it cause a shadow on the earth? Okay, so you would think this is true, but it's not, and here's why. The only way for an eclipse to occur would be if the moon is directly in between on a 3D surface, yeah? So you also got to remember this moon doesn't orbit on like a plane with the earth and the sun. It actually orbits a little off of the ecliptic plane, if you remember that vocabulary word. It orbits 5 degrees off of the ecliptic plane, okay? So you need to know that. That's why every time there's a new moon, like right here, there's a new moon for Earth. But it's not blocking the sun's light because the sun's light is going underneath it to hit Earth. Does that make sense? So the only way for you to get an eclipse is if the moon lands on this ecliptic plane and it's actually blocking the rays from the sun. So sometimes the sun's rays are going above the moon because the moon is underneath the ecliptic plane, and sometimes they're going below the moon because the moon is above the ecliptic plane, because it is 5 degrees off of the plane. Okay, that's why you're not getting eclipses every month. Okay. So you get the idea here. We get about 2 eclipses every season because that's going to happen where it falls on the ecliptic plane, usually twice a year. Okay, they're usually 6 months apart. If you're lucky, you might get like 1 more. Okay. So 2 conditions must be met for an eclipse. Okay, so you know this. It must be a full moon, and we're talking about for a lunar eclipse, right? A full moon is for a lunar eclipse. A new moon is for a solar eclipse. So in order for you to have an eclipse, you must have a full moon or a new moon, and that will depend if it's lunar or solar. And the moon must fall in the ecliptic plane, and this only happens a couple times every year, okay? So those are the 2 conditions you need for an eclipse. And that's everything. I hope you enjoyed learning about the moon. See ya.